All right, so the rest of this unit is about surface area. So you took a quiz yesterday over volume. The rest is going to be over surface area of those same figures. So what surface area is, like how to think of it, it's how much, it's like, I guess, the real life situation for this. It's how much material would be needed to cover an entire figure. So when we were talking about rectangular prisms and stuff, we were talking about presents and like how much you can fit inside the present. So surface area would be how much wrapping paper you would need. So that's what surface area is. It's all on the outside. So how much, like you're measuring just all of the faces, you could say. My son's learning about the faces of a cube actually right now. So it's how much, like the area of every single face on the outside. And what we're going to just basically be using this as is how much you would need, or like how much wrapping paper you would need. So conveniently, the first figure that we're going to find the surface area of this week or within this unit is a prism. And there are two types of prisms that we dealt with when we were finding the volume. And we're going to deal with those two again. There is a rectangular prism. That's going to look like your presents. And then there's a triangular prism. I am going to warn you that these formulas are going to be a little bit more involved, and you have to be really careful when you are using them. So we've just got to be a little more conscious. So to find the surface area of a rectangular prism, to figure out how much wrapping paper we would need for a present, what you do is you have to find the perimeter of the base. So you have to first, like we're going to write down kind of little steps that are needed or that you need to do when you're doing these surface areas, but you need to first find the perimeter of the base, so the perimeter of the rectangle. Once you find the perimeter of the rectangle, then you're going to multiply by the height, capital H, the height of the prism. So it basically would be, like in this case, for the perimeter, you're going to add the lengths together on the bottom and then multiply by the third length that you didn't use. So height of prism. And then you're going to add to that, so plus 2 times base times height, and the base and the height are again from the base. So we've got to be a little careful with this. Honestly, if there's anything I'm a little nervous about, it's teaching surface area online because I can't watch you do these. So there are definitely some places for you to mess up. I want to walk through example 1 here. Now that we have that written down, I do want to walk through one example. And then I'm going to talk about triangular prisms, walk through one example, and then if you need to, just rewind back. I'm going to try to keep these as short as possible. So for example 1, this is a rectangular prism. Okay, so when you're finding the surface area of these prisms, especially the rectangular ones, or really any of them, because I guess I'll do the same thing with triangular, you need to first identify the base. And what I'm actually going to do is I'm going to shade in the base. So majority of the time, especially with rectangular prisms, I like to use the base as the bottom. But again, a prism has 2 bases. So the bottom and the top in this case are both rectangles. So that's why I can, oops, zoom in, there we go. That's why I can say that that's my base. So this is a base, and then up here would be considered one of the bases as well. So that's what, when I'm using the perimeter and when I'm using the base and the height, it's of this base. So identify which one of those it is. Next thing you're going to do is find all variables, or find all variable numbers, I should say. So we have P for perimeter, we have H for height, we have base of our base, and then H, little h of our base. So for perimeter of the rectangle of what I shaded, for perimeter you add all the sides. So 3 plus 4 plus plus 3 plus 4 is 14. The height of the prism is the length between the bases, and that's going to be 5. It's the only time you really use the other side. And then the base and the height of the base, or of my rectangle here, are 3 and 4. It doesn't matter what order they go in because they're being multiplied. And now that I have that, I can just plug into my formula. So surface area equals P times H plus 2 B times little h. And then you just plug that in, and make sure you plug it in all at once, because you do not, you don't want to like do one thing, press enter, and then it's going to get all off. So do 14 times 5 plus 2 parenthesis 3 times 4. And my parenthesis, and I get a surface area of 94. So I would need 94 centimeters squared centimeters of wrapping paper to cover that. So if you had any questions on this one, please make sure you rewind back. Almost all of the rectangular prisms will look kind of the same. So the next thing we're going to talk about are triangular prisms. So the formula for triangular prisms is kind of the same. First thing you're going to do is find the perimeter of the triangle. So here we did the perimeter of a rectangle. Here we're going to do perimeter of a triangle times the height of your prism. So that's going to be the side that's not on your triangle, plus 2, and then you do 1/2 times base times height of the triangle. So all of this again is of the triangle. So it's a lot of things, most everything comes from the triangle except for when you're dealing with the height. And the height again is like the length between, in this case, the triangles. So let's take a look at this one right here, and let's find the surface area. So step 1 is to identify the base. So our base, if this is a triangular prism, this is a base, and then this is a base. We're probably going to use this one because it has numbers on it to help us out. So the formula that says surface area equals, we have perimeter of the triangle times the height plus 1/2 base times height. And this is again, oops, plus 2 times 1. I got that messed up. 2 times 1/2 base times height of the triangle. So once we've identified the base, then your second step is going to be like the last one. You're going to find all of the variable numbers. So we have perimeter of the triangle, height of your prism, and then we have the base of the triangle and the height of the triangle. So this base is of the triangle, this height is of the triangle, this is of the actual prism. So it's the one side that's not included in your triangle, which in this case is 6. And it's the only time the 6 gets used. So to find the perimeter of the triangle, you have to add up all of the sides. So we have 3 plus 4. Well, we're missing the third side. Great news. You know how to find that third side by using the Pythagorean theorem. So here's your 90-degree angle. Across from it is C. So we are missing C. So we're going to do 3 squared plus 4 squared equals C squared. So we have 9 plus 16 equals C squared. Add those together, you get 25 equals C squared. Then take the square root, and that missing side is 5. So this has a length of 5. So now you do 3 plus 4 plus 5. Let's see, that'd be 8 plus 4 is 12 for the perimeter. The base and the height of your triangle are the two sides that come together at the 90-degree angle, and these are the two sides that are given to you. There's your 90-degree angle. Those are your two sides. And again, it does not matter which one you plug in for base or which one you plug in for height, because they're going to get multiplied. Now we plug into our formula, and it says P, so surface area equals P times H plus 2 parentheses 1/2 times 3 times 4. So you do need to be really careful when you're plugging these in. I can't stress that enough, because there are some areas that you could mess up. So we do 12 times 6 plus 2 parentheses. Instead of 1/2, I'm going to type in 0.5 times 3 times 4. And my parenthesis, and I get 84. So if that was a little confusing, go back. You won't always have to use the Pythagorean theorem. They may give you all of them. Just be really careful today. I think that prisms for surface area are one of the hardest. So just be really careful. If you have any questions, please make sure you reach out.